Hello, today Group 4, confirmed by Felipe Bolaño, Diego Cano, Cristian Muñoz, and myself, Valeria Calderon, will be presenting our topic, Introduction to Two-Port Networks and Transmission Parameters. Introduction to Two-Port Networks. A two-port network, also known as a four-terminal network, is a mathematical model that describes an electrical circuit or device with two pairs of terminals. One pair of the terminal is called the input port and the other pair is the output port. The current entering one terminal of a port must excite through the other terminal of the same port. Importance. Two-port networks are essential in analyzing complex systems because they allow these systems to be broken down into more manageable subcircuits. They are widely used in telecommunications engineering, amplifier designs, filters, and other electronic applications. Representation of two-port networks typically represent as a rectangular block with two pairs of terminals, one on the left, input, and one on the right, output. The input and output terminals are denoted as V1, I1, input, and V2, I2, output. The most common applications are amplifiers, devices that increase the amplitude of an input signal. For example, an audio amplifier that receives a low amplitude signal and amplifies it so it can be heard through a speaker. Filters, circuits that allow certain frequencies to pass and attenuate others. For example, a low pass filter that allows low frequency signals to pass and blocks high frequency signals. It used in audio equipment to remove noise. The other is transformer, devices that change voltage levels, an AC system, for example, a transformer in a power transmission line that steps up the voltage for long distance transmission and steps it down for domestic use. Specific examples of two-port networks. Coaxial cables. It used for transmission of high frequency signals, high transmission capacity of analog signal loss, and twice pair cables. It used for Ethernet networks and telephone communications. Low cost and easy installations for the electronic engineering. Two-port networks are essential models for analyzing and designing complex electronic systems. Understanding how these networks behave under different conditions is crucial for developing efficient and functional devices.
Hello, my name is Felipe, and today I'm going to present you a little introduction about transmission parameters in two-port networks. Transmission parameters in two-port networks are a fundamental part of the analysis of electrical circuits and communication systems. These parameters, also known as S parameters, dispersion parameters, or dispersion matrices, describe how a linear system behaves when input signals are applied at one port and output signals are observed at the remaining ports. They are widely used in the design and analysis of high frequency circuits, such as in radio frequency and microwave electronics, as well as in data transmission systems. The most common transmission parameters are the S parameters, which describe the relationship between the incident and reflected waves in a two-port system. These parameters are represented by a 2 plus 2 scatter matrix, where each element of the matrix represents the relationship between the input and output signals at each port. For example, S11 represents the radio between the signal reflected at port 1 and the signal incident at port 1, while S21 represents the radio between the signal transmitted from port 1 to port 2 and the signal incident at port 1. The S parameters are especially useful for analyzing the response of a system at different frequencies, since they can vary with frequency due to effects such as attenuation, reflection, and scattering. By studying these parameters, engineers can design circuits and systems that operate optimally in a specific range of frequencies, which is crucial in applications such as mobile telephony, fiber optic data transmission, and broadcasting. In addition to S parameters, there are also other sets of transmission parameters, such as Y parameters, admittance parameters, the C parameters, which are the impedance parameters, and the H parameters, which are the hybrid parameters. Each set of parameters has its own specific advantages and applications, and choosing the appropriate set depends on the type of circuit or system being analyzed. For example, the Y parameters are useful for the analysis of alternating current systems, while the H parameters are commonly used in high frequency circuits. Choosing the appropriate set of parameters depends on the type of circuit or system being analyzed, as well as the specific performance requirements. Engineers must consider several factors, such as operating frequency, port impedance, and system characteristics, when selecting the most appropriate set of parameters for their application. In summary, transmission parameters into port networks are a fundamental tool in the analysis and design of electrical circuits and communication systems. They provide valuable information about how a system behaves based on input and output signals, allowing engineers to design systems that meet specific performances requirements in a wide range of applications.
Now I'll talk to you about ABCD parameters or transmission parameters. The ABCD parameters, represented by a 2 by 2 matrix, establish a relationship between the incoming and outgoing voltage and current waves at the two ports of a network. They are defined as follows. V1 and V2 represent the input and output voltage. I1 and I2 represent the input and output currents. A, B, C, and D are the ABCD parameters. The ABCD parameters capture the essential characteristics of a two-port network, including its voltage gain, current gain, input impedance, and output impedance. They provide a compact and systematic representation of the network's behavior, making them available for circuit analysis and design. Applications of ABCD parameters. ABCD parameters find wide applications in various areas of electrical engineering, including signal transmission and analysis. ABCD parameters are employed to analyze the transmission of signals through two-port networks, enabling the calculation of signal power transfer, reflection coefficients, and matching conditions. Impedance matching. Impedance matching is crucial for maximizing power transfers between circuits. ABCD parameters are used to determine the appropriate impedance transformation required to achieve optimal matching. Cascade connection of two-port networks. When connecting two-port networks in cascade, ABCD parameters are used to calculate the overall ABCD matrix of the cascaded system, simplifying the analyzing of the overall circuit. Parameters are used to calculate the overall ABCD matrix of the cascaded system, simplifying the analysis of the overall circuit. Filter design. ABCD parameters play a significant role in the design of filters, which are used to selectively pass or attenuate specific frequency bands of signals. Calculating ABCD parameters. The calculation of ABCD parameters depends on the specific two-port network being considered. For simple networks, such as resistors, capacitors, and inductors, The ABCD parameters can be derived directly from their circuit elements. For more complex networks, alternative methods are employed, such as S-parameter conversion, S-parameters, or scattering parameters are another set of two-port network parameters. The conversion between ABCD parameters and S parameters is straightforward and can be used to calculate ABCD parameters from S parameters. Transmission lane analysis. For transmission lanes, ABCD parameters can be derived using transmission lane equations, which describe the propagation of waves along the transmission lane. Finally, circuit simulation software. Circuit simulation software packages often include tools for calculating ABCD parameters of various two-port networks.
Hi, my name is Christian and I am going to talk about examples of two-port network. A voltage divider is the most common and simplest example of a two-port network with resistors. It is used to divide a voltage signal into two proportional parts. A two-port network with resistors is made up of two resistors connected together in different ways. This network uses passive electronic components such as resistors to modify the signal passing through it. The technology is simple and inexpensive, making it ideal for basic applications. Other example is two-port network with operational amplifier. An inverting amplifier is a slightly more advanced example of a two-port network with an operational amplifier. It is used to reverse the polarity of a voltage signal. A two-port network with an operational amplifier uses this active electronic device to amplify or modify the signal passing through it. The network is characterized by its voltage or current gain, which depends on the configuration of the operational amplifier and external components. Two-port network with filter. A low-pass filter is also a common example of a two-port network with a filter. This is used to remove high frequencies from a signal. Ethernet is the most famous two-port network. Ethernet is a local area network technology widely used to connect computers, peripheral devices, and other equipment. It is based on an open standard that defines the physical and electrical characteristics of the network, as well as communication protocols. Ethernet uses copper or fiber optic cables to transmit data. Ethernet is used in a wide range of applications, including office network, home network, industrial networks, campus network, data center networks, and others.